start by understanding what a digital comparator is. In digital electronics, a magnitude comparator is a combinational circuit that compares two binary numbers and determines their relationship, whether one is greater than, less than, or equal to the other. These comparators are fundamental in various applications, from CPUs and microcontrollers to control systems, where binary values represent physical quantities like temperature or position. Basic idea is simple. You provide two inputs, usually labeled A and B, and the comparator gives you three outputs, A, B, and a B. This logical decision-making is essential for automation and digital decision processes. Now let's see how this works in practice, starting with the simplest case, the 1-bit comparator. 1-bit comparator is the simplest form of digital comparator. It compares two single bits, A and B. The circuit uses basic logic gates like XOR and not to determine the relationship between these bits. For example, if both A and B are 0 or both are 1, the output A equals B will be high, indicating equality. If is 1 and B is 0, the output AB will be high, and if is 0 and B is 1, the output AB will be high. On the experimental board, you can use switches to set the values of A and B, and LEDs will indicate the result. This hands-on approach helps you visualize how digital logic translates into real-world outputs. The 1-bit comparator forms the foundation for more complex comparisons, such as the 4-bit comparator. Moving to a 4-bit comparator, the concept is similar but scaled up. Here, each input A and B is a 4-bit binary number. The comparator checks each bit, starting from the most significant to determine which number is greater or if they are equal. The logic involves more gates and sometimes cascading, where multiple comparators are linked to handle numbers larger than 4 bits. On the experimental board, you use 8 switches to set the values for A and B, and the outputs are displayed via LEDs. This setup allows you to verify the truth table for all possible combinations. Cascading comparators is essential for comparing numbers in larger digital systems, making this experiment a stepping stone to understanding more advanced digital logic. Digital comparators are widely used in real-world applications. They're found in CPUs, microcontrollers, process controllers, and even in security systems like password verification and biometric checks. When conducting experiments with comparators, always handle switches gently to ensure their longevity. Carefully follow the procedure before powering up the board to avoid mistakes. By practicing with 1-bit and 4-bit comparators, you build a strong foundation for understanding more complex digital systems. This knowledge is crucial for anyone interested in electronics, automation, or computer engineering. Remember, mastering the basics of digital comparison opens the door to advanced logic design and practical electronic applications.